I've been doing sort of machine learning for a long time, got out of science, figuring that I actually didn't want to be an academic and wanted to make money, and so went into the field of machine learning. Been doing machine learning at B2B companies, so really working on AutoML and delivering that for a long time, and then basically went to Pharos when I decided that maybe it is, which is a platform for engineering operations, data platform for engineering operations information, when I realized after bopping around these various companies that maybe it is an interesting question whether, why some engineering orgs are good at shipping things and some are less so. And to do that, I wanted to look at the data. So for this talk, I should say that I have never been more concerned that I would show up to a conference and give the same talk as everyone else. And I will say that there have been many great talks yesterday and probably today as well on LLMs, and it has covered some of the same ground. But I will try and say it with some new insights, and at least with my slide titles in the style of Terry Pratchett as given to me by an LLM. And so I will try to entertain you. And the first thing that I want to talk about is really how we ended up here, how it ended up being the case that I had to give a talk on LLMs because this is what we're doing. If you'd talked to me in January, this is not what I thought I would be working on at this point. And so what are good use cases for them? Why are we so obsessed with them? And what are we doing with them? And then I'll go through the actual use cases that we're doing at Pharos and how we evaluated them and decided that these were good use cases. So the last couple of years, as I'm sure you're all aware, have been just this explosion of foundational models, which really changes the way people think about machine learning, because you don't have to spend a year developing a model to do a particular task. You can just sort of grab this off-the-shelf thing, and it will give you an answer. So, you know, we're either in the future or in your favorite fantasy where you can just walk up to Hex, the supercomputer, and it will give you a written language answer to any question you can ask, or an out of cheese air, whichever is the right thing to do. And so we've gotten to this point where just everyone is working to integrate LLMs into their software. And I was talking to companies this summer, and it's just across the board. Everyone wants LLMs in everything. And so the first iteration of this was just with text to image, right? And so this is fun. You can generate fun images, but it was really more of a party trick, right? Like, go to a party and you're like, can we make this thing produce an image? And you laugh about it. It's not this transformational thing for most tech companies. It certainly had a big impact on creative communities, and there was a lot of debate of like, what's the role of humans? Does this sort of make them obsolete for a lot of these jobs? We got great memes out of this, which is fun. But I think the conclusion was more along the lines of, no, you still need humans to get good creative work out, to get the right thing. You want humans to do it, so it's really a tool. And it didn't affect me nearly as much. But we get to LLMs, and everyone's just crazy about them. Like, why is it that if you can put in natural language, everyone wants to do this? And I think it's really just because language is so important to humans, right? It's one of the things that makes humans what they are, and it's been defined as sort of this stepping stone of like, other animals don't have this. So there's a lot of work in neurobiology showing that other animals do have very similar things. They can vocally learn, they can do these things, but linguists sort of go back and then redefine what language means to say, no, it's this complex ability to define any abstract concept with words, and that's what makes it human. I think this is a little bit the case of defining a metric to get the answer you want, which is also something that seems to happen with emergent properties in LLMs. But nevertheless, it's hard to overstate how important it is. We wouldn't be here at this conference talking about all of this fantastic technology if we hadn't figured out how to write down information about that and share it with lots of different people and learn on top of it. And so this really does seem like a building block. And if you haven't read it, I highly recommend the blog from Stephen Wolfram, What is ChatGPT Doing and Why Does It Work? It gives a great explanation of sort of how these models are functioning and sort of highlights the difference between being able to produce language and being truly intelligent, right? And I'm going to spend several slides on this just because I've seen it so much in the news and it kind of irks me. So there's this idea that these language models are just predicting the next token. And it's predicting the next token based on learning from a vast amount of data, right? More written language than humans could really take in and learn from, but it's still predicting the next token. And I just want to say that, you know, the word apple, to me, is a lot more than the next token. It's a lot more than the word before tree or sauce. It's thought and feeling and a taste and a memory of apple orchards. And I think that's really important when we worry about sentience and intelligence and what these machines will do. And just to go a little bit further than that, I'm going to pull on neuroscience just a little bit. So this is a figure from a paper called Language and Thought Are Not the Same Thing. And what this is showing is actually two areas of the brain that are involved in language. And this is language comprehension and language production at this higher level of saying, like, you can convey information, you can understand it. And the areas not highlighted in red are actually other language areas that are not this higher level. So they're motor production of language, seeing and understanding language, so perception. These are excluded from the study. And what this shows in both functional imaging and studies of people who have had strokes that damage these areas is that you can do other important thoughtful things without these areas, without language. And so this chart next to it basically shows that during language here, you can see that these areas are highly active for sentence production and things that sound like words, but for doing things like math, which requires a great deal of thought, or doing things like working memory, so remembering one thing after another, like Donald Trump can do, or basically cognitive control, so navigating through space using definitions of things rather than geometry, or music. These areas are not involved in that, and in fact, you can still do all of these things without those areas. So there really is more going on in human thought than just predicting the next token, which isn't immediately obvious. Like, it's hard for me to say that what I'm doing right now is not just putting the next token, saying the next word after what I came up with before, right? But it really is different. And if you look at the complexity, these models are, you know, very, very big. I'm going with Llama 2 here. I refuse to speculate on the size of architectures that are not open sourced, but this is a lot of parameters. It's a lot of weights to fit, and it's trained both on just the vastness of everything that we've written and reinforced to produce answers that are good for humans, that we like to see. So it sounds right. But again, nature is more complicated. So if we just take a little stroll through Wikipedia and look at the brains of various animals, llama, smarter than a sponge, right? There's no neurons in a sponge, it just sort of exists. But you don't have to go very far to get much more complex. So you can see honeybees actually are quite complex animals. They have about 1 million neurons. They have about 1 billion synapses, which is the equivalent of weights in these, so it's the connections between neurons. I'm going to leave aside the fact that animal neurons are orders of magnitude more complex than the neurons in these models. But you can go just a little bit further and see that a mouse sort of blows these models out of the water. And so my point here is that maybe we should just spend the same amount of time worrying about these models being sentient as we worry about mice being sentient, which is not to say that mice are not cool and we shouldn't spend some time worrying about it. They can vocalize. They might be doing a giant experiment on us to see whether or not they can figure out the meaning to life, the universe, and everything. But it's still not something most of us spend a great deal of time on. It's not the same level of news cycles. So we're back to this idea of talk. Because these models can talk to us, we feel like we can use them for anything. And I have seen many proposals of people trying to use them for everything. And they're a fantastic multi-tool in many ways. But a multi-tool isn't always what you want, right? Like it's cool, it's fun, it's an interesting place to start. But if you're going to do a serious woodworking project, you probably don't want this AI-generated contraption for it. You probably want some real tools. And I think that's maybe the lesson is like, you can get started with this, but it's maybe not the end goal. And so one of the use cases that I've seen permeating this is just this idea that you use these models to help you write articles and information, documents. I was super excited when they came out. I'm like, I'll never have to write another technical document. I can just write an outline, and then the LLM will fill it in for me. But if you've done this, you'll realize that it tends to fill it in with very generic information and not necessarily make your points. And so I did just a little experiment to do this, saying, if we get to the point where we're having these LLMs write our information, which many people are, and no one has time to read all of that generated information, so of course we're using LLMs to summarize this as well, and then you use those summaries to generate new documents, sort of what happens to the information, right? And so I did this. I took the outline for this talk that I showed you at the beginning, and I fed it into an LLM. I said, write me an article. And then another LLM, summarize it. Another LLM, write me an article. And then I told the final LLM to summarize it for me. And what I got back was still on LLMs, which was really impressive. I wasn't sure that was going to happen. But it has no resemblance to what I fed in. It seems like something that was probably specifically trained into these models to return as the way the companies that supply them want LLMs to be talked about. It's just sort of a very different thing. And I think this is an important piece to keep in mind as this is sort of permeating the information that we see in the world. And again, like the use cases that we have, the use cases that people want to do, there's a lot of different dangers and different harms that could come from them. And so there was a great image chart from Alexander Tulkanov early on when these came out, and it's just this question of like, when is it appropriate to use an LLM? And the first question, very importantly, is, do you care if the answer is right? If you don't, go for it. But like, if you maybe care, then you should consider whether or not you can tell if the answer is right. And this is really tricky because it is hard to tell sometimes if the answer is right. The LLMs produce very convincing hallucinations or just like mistakes, things that look like they would be produced because we've trained them on all of the things we've produced, all of the garbage and all of the actual information. And if you're not willing to, if you can't check it and you can't assume responsibility for it being wrong, then don't use it. And I think that this is increasingly important. And even if you can take responsibility for this, even if you don't care if the answer is right. So this is an example of someone just goofing. This is a real screenshot from my phone. Someone just goofing around with an LLM trying to get it to say something funny, and it became a sensation on the internet, and then it became the informational blob on Google for the search of what do you countries in Africa that start with K, and then you get this like seemingly informational piece of thing that says no, there's no countries in Africa that start with K. The closest one is Kenya, which starts with a K sound, but is actually spelled with a K sound. Like, this is obviously wrong, but there are many examples of things that are less obviously wrong. And so you need to be aware that this is already happening. This is already sort of polluting our information space. And then, of course, the question of these are really, really big models, probably unnecessarily big models for many of the tasks that they're being used for. And people are just sort of sitting around, talking to them, playing with them, and filling the atmosphere with carbon. So there's many harms here. There's a great paper out of DeepMind that lists these as well as all of the sort of maliciously harmful things that people might do. I'm not going to focus on those so much as the things that we could accidentally do, because I think we're not trying to do harm with these models here. But it's still possible to carelessly decide to use them for the wrong thing. So what are good things to do with these models? What are good jobs for LLMs? And again, language is a really powerful and natural interface for users. It's much more natural than than the whole like web computer interface that you sort of have learned as a child. So you're very familiar with it, but it's not the thing that humans have evolved for millions of years to do. And so being able to interact on that level and put this information into language becomes really powerful. And so the things that we decided to try first at Pharos were two things, basically to make data access easier. So the first is just putting captions on charts. So a picture may be worth 1,000 words, but it really helps to have some words to explain what the picture is about. And so we wanted to automatically capture that and give people an aid in viewing sort of a complex dashboard that they may not have experience with and really understand it. And then, of course, there's this thing of it's actually really hard to formulate a good question given a brand new database and schema and make sure that you have the right answer. And so we wanted to provide an aid for that. And the way that we did this, I'm going to talk about Query Helper and not so much about Chart Explainer for this, but we focused mostly on using LLMs as an aid. And I should say that I joined Pharos fairly recently, and so much of the work that I'm going to talk about was not from me. It was like my dream job of showing up and being an intern. Other people had already thought of the project. I just had to implement. It was great. It's how I want to retire, basically. Just do it. Don't have to think about what you're doing. But much of the work was done by my 3 times colleague, Kin Can, shown here, as well as a lot of work from Sarah Asher, Natalie Casey, Shuba Nabar, and Chris Rupley in terms of just defining what should be done. So I want to give them the credit for actually thinking about these projects. But data is hard. This is a real screenshot of the schema at Pharos, and it looks terrible, but it's not. It's not actually a bad schema. It's only 58 tables, and it's well laid out. It's got good connections. It's standardized across all the customers. But if you've ever started at a new company and had to figure out where the data lives and how to connect it and what to do with it, it's hard, right? It takes a lot of time to learn, and it is easy to make mistakes, and make mistakes that really give you the wrong answer in a critical way. And so we wanted to make it easier to approach this and have our customers not have to spend a ton of time figuring out how to use the product. And so in order to do that, we wanted to make a helper. So this is what the UI looks like. This is the final product that we made. And what it is the ability to type in your question about what you're doing, and then we will go and return related charts, related visualizations and summaries that have already been made within your piece. And we improved this using LLMs as well, so we improved upon the basic search. And then we also create a textual how-to guide. So this is how you're going to get your data, this is what you're going to do with it, and this will answer your question. And then importantly, we parsed out the table information from this LLM-generated how-to guide and enriched it with handwritten instructions and information about each table to say, this is how this table should be used, this is the join keys, so that the user can actually look at the instructions, verify with the information about the tables, and just sort of quickly understand what they're trying to do. So putting some of the ability back on humans, because we're really trying to build a tool to make it easier for humans, not have this replace the humans. And I'll talk a little bit about whether or not that should be the end goal. But of course, in building this, the first thing you have to ask is, are we doing it well enough to ship it in front of people? So please don't try and read this, but this is just a picture from a review article of all the different ways that people try to evaluate LLMs. And they do this basically because they're trying to evaluate them for everything, right? So you're trying to evaluate whether or not this LLM can pass the LSATs and write SQL and write code and do all of these different things. And I don't actually need the LLM to do everything. It's cool that it can, but that's not what I'm trying to do, right? I'm trying to do a specific task. And so there's other ways of evaluating, such as the Hugging Face Open LLM Leaderboard, which allows you to look at various models' performance on particular benchmarks for particular tasks. And you can use this to pick your model, which is great. It's a good start. It's still not your task. It's still not evaluating that, which is tricky. And it's become sort of more and more common for people to just say, well, I can't figure out how to evaluate this. I'm going to feed it back into the LLM and ask the LLM how it did. I think we can do slightly better than this, and there are a lot of problems with this, not the least of which is that these models have been shown to prefer their own outputs. And so they're more likely to judge themselves as good above humans, above other models. And so I think it's a little bit too much feeding pigs bacon to really provide a good answer here. So how are we going to do this? We're going to focus on what matters. Does the spelling in your AI-generated picture matter, or just the fact that it looks like what you're trying to do? We defined particular metrics that we wanted to do and kept in mind Goodhart's law, which is that the metrics are not the actual goals. So we refer back to the metrics, look at the actual data, and evaluate based on that to make sure that they're really capturing what we're trying to do and not just something that we're optimizing for. And so the metrics that we decided to use were Rouge 1 and Jacquard similarity. And the Rouge is a classic summarization metric. It's basically looking at n-grams. In our case, we just looked at single words, single n-grams for the summary and a reference. And the overlap between those. You can do this as the classic definition is of recall. We used a library that also calculated precision in F1, which is the harmonic mean of precision and recall, and we chose to focus on F1. So basically the similarity between your reference explanation and a generated explanation. And then it was really important to us that the tables that were recommended be correct. This was sort of the most important part. Can it find the right tables to do? And so we used Jacquard similarity, so the intersection of the tables in the reference and the generated response over the union in order to do that. And we did this for both the individual table names as well as all the tables plus fields that were done. And so the first question is, where do you get these references to compare your LLM results to? And what we did is look at our dashboards that are written by us, by the engineers and data scientists at Pharos, and use those as examples of correct usage of the schema. And so each of these dashboards contains many charts. If you take the title of the chart as the question and then look at the underlying information used to generate the chart, you can provide an explanation for how you got that chart. And so we did that, and we did a number of iterations of how this was done, both by hand and using LLMs, which I'll go into in later slides, and found that it's really important to have a lot of explanations and to have really good explanations. And the explanations look something like this. So basically, for a question, time to resolve incidents, we have a primary data source, the join information, the filter information, the breakout information, and finally, any aggregation. And you'll notice that this is very similar to SQL, but we do not directly expose SQL to our customers. And so this is just an explanation of how to use a UI in order to get the information. So the first thing is, like, how did this work? How do we get the right prompt? Can we get an LLM to perform well? And so this is the information based on tables. So did it produce the right tables? And we did this in a number of different considerations. So with no examples. So zero shot, we just gave it some tables and asked, can you tell me which tables I should use to answer this question? And it did okay. If you gave it examples, just particular examples, it actually did much worse. And so if you give it static examples that don't have anything to do with the question, it will sort of over-index on those examples and give you answers related to the examples and not the question. But if you give it relevant examples, it does much, much better. And more examples or more tables don't actually help this. So looking at, in addition to the tables, you can look at the schemas, so the field information that it does. What we found is that without examples, it actually failed to put things in the correct format, and so we couldn't parse out the field information. You needed some examples to get the right formatting for this, but again, like, more examples, relevant examples, was really the way to get better performance. And the same with the format. So the overall format of the explanation was better as you went to more examples, better examples. And so we spent some time really thinking about like, so in RAG, it's not about the size of your prompt. It's not about stuffing all of the information in. It's about getting the right information, just the right information, into your prompt so that you can answer the question. And this is really critical. And so in order to get the right information, we actually looked at how to generate these examples. We used LLMs to do the generation in a number of different ways. We used manual explanations. We generated it from the underlying SQL that accesses the data, from the JSON that generates the data, and finally, we went in and manually fixed the JSON information in order to get better results. So it was this combination of, you can use LLMs to bootstrap your data, but you're still going to have to spend time making sure that that's quality data, because that is the most important thing, is really getting good data. And so, all right, I'm gonna give this last piece of new information, and then I'm gonna hurry on to the end because I've way overspent my time. The last piece was picking which model to use. And so we started out with OpenAI and had a lot of issues with timeouts and basically token limits and outages, and it was just really, really slow. And so we moved to trying AWS Bedrock with Claude v1 and v2 and found that it was much more reliable. It turns out AWS is good at being a platform. And so we did this, and then we looked at the overall quality. This is one example, but there were many others, and found that there's not really a significant difference in the quality across models. If you squint, maybe you could decide that you wanted GPT-4 to be better here, but it was not significant. It was not visual. You'd need to do like many thousand more trials in order to get a real difference. And so it was certainly not enough to make up for this nonsense. And so we went with Anthropic through Bedrock. So in order to build this, we did a number of things. So we used LLMs to basically introduce semantic search into the related charts and then re-rank the information. We used prompt engineering to get as much relevant information as possible into our LLM query and really make sure that that query was performing well. And we then parsed that in order to give additional details about the data so that the customer can make the right decision in how to use it. And so the end point of this was that we got something very, very quickly that we could ship in front of customers and see if they were interested in it, see if they cared. And what this means is that we didn't have to spend a year building a model to see whether or not it was worth doing. We can put this out, we can monitor whether people respond to it, and if they care, then we can iterate, then we can make it better. We can see whether or not we need to fine tune. We can see whether or not it's worth the investment of doing models, whether or not we can ever get to the point where we can automatically generate the charts. And I think the answer to that is not with the current iterations of these models, but maybe someday, maybe with something more specialized that's not sort of this multi-tool that can also do the LSATs, but something that's really specific to SQL, like we saw in some of the talks yesterday. We'll be able to get to the point where we can trust it to do this well. So in the future, you can just ask a model to give you a holodeck, and it will give you something that looks cool and is vaguely related to the thing you were thinking about. And so it really is powerful, but it's not quite to the point where we need to lose our minds. And I think that's sort of the lesson that we took from here, is that if you take this multi-tool and think of it as just like a new way to quickly iterate on shipping an AI product and make sure that you evaluate it, make sure that you have a good business goal, it's really quite fun and powerful, but not necessarily something we need to lose our minds over. And you should still make sure that you have a good business goal in using LLMs. So thank you very much.